All right, today we're going to go over the Autometer BCT-460 battery and system analyzer. I'm going to kind of go over some of the features of the tester and some of the accessories. So right here you have it's a battery wall mount charger, so you can hang up your BCT-460 when it's not in use to keep the battery charged. We have all the adapters needed for testing batteries. These would be your battery adapters. They're brass adapters, good conductor. We also have alternator adapters. They'll fit any type of alternator, any type of output stud on the alternator or the ground stud. Then you have your starter adapters for easy connection to the starter. Sometimes that starter is a little tough to get to, but the tester or kit comes with these adapters to easily connect to the starter. We have your external volt leads for doing voltage drop checks or testing the alternator. We have the wall mount plug for if you didn't have the wall mount charger, you could just plug it into a 110 outlet and charge the battery. Then we have the tester itself. The tester here is a tablet-based tester. Gives you the flexibility to remove the tablet and make it easy to, for example, like doing an alternator test where you have to climb in the cab. It sure makes it easy to have this tablet with you when you're doing that. So kind of go over some of the features of the tester. The tablet itself is called the control module, and the base is your load module. This is what actually applies the load to properly test the batteries or do your alternator or starter tests. The first thing I'm going to go over is kind of just checking the battery status on the control module and the load module. The first thing you want to do, it's a Android tablet, so if you're familiar with that. On the side here, there's an on-off button to turn the tablet on. So the first thing I always do is I go to these, there's three little dots up here in the right-hand corner. I just want to go click on that, and I'm going to check my battery status. I'm going to hit the battery status button. And this gives me a readout of what the state of charge is of the control module. Again, that's my tablet, and my load module. You can see my control module is at 90%. And right now it's saying my load module is at 0%. That's probably because it's not paired with the tablet's not paired with the load module. So that's the first thing you want to check before you begin any kind of test. So now I'm going to show you how to pair the control module with the load module. First thing you want to do, once you have the tablet removed, you'll see this little button right here. And below it explains what the button does, what the LED on the bottom of the tester is meaning. When it's charging, it'll let you know when it's charging. When it's discharged, it'll let you know when it's discharged. But to pair the control module with the load module, you just want to hit that button once. And you can see the load module went up in percentage of charge, so you know that the control module and the load module are paired together. So now I'm going to put my control module back in its holder. Another feature is a couple more features. That's a really nice feature for making sure your clamps are stay in good condition. They provided a couple places for you to stow your cables when you're completed. So you can clamp on your positive cable one side, negative cable on the other side, and it kind of keeps those cables protected. It's very important to pay close attention to your cables when you're load testing batteries. Oftentimes there's a lot of dielectric grease, gunk and grime built up on the batteries. That tends to get built up into your clamps, and you want to make sure you keep those cleaned out as good as possible. There's one side of this is the load side, and the other side is the sensing side. You can't just replace these cables, with just any cable. It's special cable that has a sense wire built into the wire. If you need replacement cables, call Autometer. They have part numbers. They'll get you set up with cables. Another feature that I like is, when you're doing an alternator test or starter test, you want to make sure you secure your tester there's going to be a lot of vibration going on under the hood, so you want to make sure you secure the tester to keep it from, falling down in the fan, falling and hitting the floor. Just keep it protected. They give you a nice little hook so you can hang it, anywhere underneath the hood to be able to easily see the tester, but yet protect the tester. One other feature that we're going to go over is how to connect to Wi-Fi. There's a license that you can purchase with this Autometer tester. It's called the AmpNet site. Basically allows you to remotely view all this data from anywhere. But you have to be connected to Wi-Fi to be able to do that. First thing I'm going to do is down here on the bottom is your home button. So you can hit that home button. Go to settings. And this is where you can set up all your address, all your location information. Then you can set up all your default settings. Setting up default settings as far as your CCA, your cold cranking amps, seeing the last CCA and remembering that. A lot of your default settings are going to be in here as well in the settings. But down here there's a button called Wi-Fi setup. So you're going to hit that Wi-Fi setup, and just like you would on any device, you just pair it with the Wi-Fi before you use AmpNet. But I just wanted to show you where that's located so you can properly set that up. So going back to the home screen, you have several options. You got full system test, light duty, heavy duty, individual tests. You can review all your results. We already went through settings and about that full system test is basically it's going to give you that. It's almost like an investigation. It's going to walk through several questions to really get down to that root cause of what's going on with that system as a whole. So today we're going to go over troubleshooting the charging circuit and the cranking circuit, and what we're going to do, what we're going to go in to do that is all our individual tests. So I'm going to click on individual tests. It gives you six options to pick from. You have battery test, alternator test. You can use this thing as a voltmeter, to where I can look at ripple current. I can look at what my voltage is on my large clamps, what my voltage is on my small clamps. So if you just wanted to use this as a voltmeter, it has that feature. You also have voltage drop tests. You can test a starter. And then if you had a current probe, you actually measure current as well. So going into review results, this gives you a list of all the results that were done in this tester. And it gives you neat little symbols out to the side. If it's green, it's good. If it's bad, something happened in that test that deemed that starter, that alternator, or that battery bad. But it gives you a little symbol of what an alternator is, a starter test, and then a battery test. So you can quickly go down and see all your results. Today we're going to go over how to properly troubleshoot the charging circuit and cranking circuit in a Class 8 heavy-duty truck using the BCT-460 Autometer system analyzer and battery tester. The first step you want to take in any electrical system is you want to start with the heart of the electrical system, which is the batteries. You got to make sure you have the power there before you go into any kind of diagnostics. So we're going to start with the batteries. The first thing we want to do is do a physical examination of the batteries. You want to make sure there's no dirt leaks or cracks, to make sure that battery's in good condition. Check all your connections, the lead pad, make sure there's no corrosion built up, because all that's going to build up resistance in that circuit and could cause you issues. It could very well be the issue that you're dealing with. So the first thing is inspect all your connections, look at the batteries, make sure there's no cracks in the batteries. Very important part is the battery hold downs. Make sure your battery hold downs are in good condition. But in order to properly test these batteries, when diagnosing a cranking or charging issue, is you want to separate the batteries. So that's what we're going to do. We're going to separate these batteries. So using a 9/16 wrench, I'm going to take off the battery nuts. Some of them are a little tough to get to, but so I'm going to remove the inner cell connectors. Some of these battery boxes are configured, they're all configured differently. So a good thing to do, just to remember how everything goes back together, might take a picture of it, just some of the way the cables are routed, positive and negative cables, you definitely don't want to get them mixed up. So it's a good practice just to kind of take a snapshot of those batteries, just so you can put the cables back on correctly. Okay, so I have the batteries all separated. Get my hands cleaned off. So you want to inspect the, like I mentioned earlier, you want to inspect that lead pad. That is the lead pad on that battery, that is your electrical connection. The battery stud itself is made of stainless steel, fairly poor conductor, so it's really just meant for a mechanical connection to really keep those cable lugs secured down on that lead pad. You also want to make sure that lead pad is completely flat. If there's any buildup in heat, that lead's really soft. Those cable lugs could have made indentions in the lead pad, which is going to result in high resistance. It could be the cause of your electrical issue. So you want to make sure that lead pad's really clean and really flat. I like to use these battery brushes. They make one for the battery, the lead pad itself. They also make one for your cable lugs that has a piece in the center, a wire brush in the center, that makes it really easy to clean cable lugs. So that's what we're going to do next. We're going to clean our batteries. So you can use this battery brush, inside of a drill. You can use it by hand. You can use just a standard, wire brush. But any kind of wire brush to clean that lead pad really good. So that's what I'm going to do now. I'm going to clean that lead pad. Make sure there's no corrosion buildup. And then also make sure that my cable lugs are clean. You can see here, there's good dielectric grease on the cable lugs. They're all really nice and clean. That's not going to cause me any issues later on down the road. So that's the first and most important part, is making sure your connections are clean. Another thing you want to do is make sure you clean off the battery. Take the time to clean off that battery with that dielectric grease that they put on, the moisture, the road spray. That's all going to build up on top of that battery. So you want to get that good and clean. I've even seen where you get so much dirt and grime buildup on top of that battery that can actually conduct across the positive and negative studs. So, and plus, during the test, you got to enter the CCA, the battery date code, all that stuff. If the battery's really dirty, you're not going to be able to see that. So now we're going to use our adapters included in the kit. They're brass adapters, and we're going to screw those down onto the battery. And just make sure they're good and snug on top of that battery. Use my 9/16. And now I'm going to use my tester to load test these batteries. So I'm going to turn the tester on. Again, we're going to go into our individual tests. When you're diagnosing or troubleshooting charging or cranking circuit, you want to go into the individual tests. So it gave me 6 options to pick from. I'm going to start with my battery test. And the first thing it asked me is how many, enter the number of batteries in that pack. Well, looking at it, I have 3 batteries in this pack. But again, I'm doing an individual test. I've got the batteries separated, so I'm going to select 1. You can either pick 1, 2, 3, or 4 batteries. So I have 1 selected, I'm going to hit OK. Then it pops up another screen that says select the battery rating. It gives you multiple the battery ratings: CCA, cold cranking amps, MCA, marine cranking amps, CA cranking amps, just different battery ratings that you can select from. But we're going to stay with CCA, cold cranking amps, and we're going to enter. Below here it says enter rated CCA. So I'm going to look on top of my batteries. Another reason why it's important to clean those batteries, because I got to see what the CCA is. And the CCA on these batteries are 730. So I'm going to enter 730, hit save. Now the next thing it's going to say select the battery type. You got three options to pick from here. You have standard flooded cell, which is what we're working on today. You have AGM, which is absorbed glass matte batteries. Then you have AGM, absorbed glass matte batteries with pure lead. North Star, Odyssey, those are 2 battery manufacturers that produce pure lead batteries. But we're going to stay with standard flooded cell. But it's really important to select the proper battery type. AGM batteries and even the North Star Odyssey batteries have different charging and discharging characteristics, and they're built a little bit differently. So you want to make sure you really understand what batteries you're using and select the proper battery type. The next thing is measure the battery temperature. So I'm going to hit enter. Then it pops up a screen and gives you an illustration of how to measure the battery temperature. On the back of the tester, there's an infrared probe so you can measure that temperature. First thing, you have to have the batteries, you have to have the clamps connected to the battery before it'll measure temperature. So you want to observe the polarity on the battery, hook the red cable to the positive side, negative cable to the negative side. Hold the tester about 6 inches away from the batteries. And again, these batteries are reading about 51 degrees Fahrenheit. So we're going to hit save. Save. So now we're ready to do the battery test. Below it gives you a little analog meter as well as the voltage reading. So these batteries are sitting at about 12.6 volts. So we're going to hit the start battery test. And it gives you a progression line. And gives you results. So it's saying I have a good battery. My rated CCA is 730. I actually measured 847 CCA. My loaded voltage was 11.61 volts. My state of health, I'm at 100% state of health on these batteries, or the battery that I'm testing. And then my state of charge is 96%. And it'll also give you those same readings in a little analog reading below. If you are connected to Wi-Fi and do have the AmpNet license, there's a blue button at the bottom. It'll light up blue if you are connected to Wi-Fi, and that's labeled as AmpNet. You can hit that button, it'll automatically upload that data to the cloud. Or when this tester goes to sleep, that data will be loaded to the cloud, so it can be reviewed remotely. So that's it on testing a battery. You want to repeat those steps for the next, for every battery in that pack. So like we discussed, the BCT-460 is very intuitive. And then when you get in situations where, especially like the starter connections where you can't see it very well, if you connect the cables in reverse reverse polarity, it's going to let you know that. It's not going to let you do anything to harm the vehicle or do any kind of harm to the tester itself. So right now, simulating doing a battery test. I've got my negative lead connected to the positive side and my positive large clamp connected to my negative side. So immediately pops up on the screen, my clamps are connected in reverse connection. My clamps are reversed. So again, it's not going to do any harm to the tester or the electrical system on the vehicle. So simply correct the cables and proceed with your test. So now we're going to go over how to troubleshoot or diagnose the charging circuit and the main cables. Now that we've tested our batteries, we know that we have a good battery pack. Now we're going to make sure, can we deliver that energy from the battery to the starter? So we're assuming that this truck does not start right now. So utilizing the BCT-460, we're going to go into individual tests. And we're going to do voltage drop tests. So we're going to check our cranking cables, starter main cables. You have five different options here. You got starter main cables, charging cables, magnetic circuit. So if you have a mag switch on the firewall, you can test the voltage drop across that mag switch. Generic voltage drop, so you can just do a voltage drop on any set of cables. Then there's some lift gate options. If your fleet has lift gates, you can do voltage drop on lift gates. So we're going to go into, since we're troubleshooting the cranking circuit, we're going to go into starter main cables. Nice thing about this tester is it gives you a little hookup diagram. It tells you exactly how to connect your leads in this circuit. So the first thing I'm going to do is I'm going to, exactly what the tester says. This tester is very intuitive, so it walks you through step by step and gives you pictorial diagrams on how to do everything. So connect the large leads to the starter, connect the small leads to the starter battery pack. So we're going to start with our large leads. And you want to make sure, if possible, that you utilize the battery adapters, the brass adapters, when you're connecting your large leads to the battery. Just want to make sure you have a good electrical connections to that starter. So I'm going to put my leads down here. Negative to negative, the ground post on the starter. A lot of times on these starters, they like to put, I don't know, the Gliptol spray or even paint to insulate those connections. That tends to be really tough when you're trying to make an electrical connection with these clamps. It kind of is what it is. You got to kind of clean those studs off to get a good electrical connection. The tester will not let you proceed unless you have a good electrical connection. So I've connected my large leads. Now I'm going to connect my external volt leads, or my smaller leads, to my battery pack. Again, we talked about that hook. Makes it nice and easy to hang it somewhere while you're doing this. But I have banana plugs on the end of the test leads. So I'm going to plug them right at the bottom of the tester. Red to red. Black to black. And then I'm going to go back here to my battery pack and connect my small leads. So we're testing the starter main cable. So we're going to put my black lead on the negative post where that Starter main cable's coming in. And my my red alligator clamp, where that positive starter cable is coming in. I've got to measure 2 points in this circuit to properly measure that voltage drop. TMC RP 129A states that you're allowed a 1/2 volt drop at 500 amps in this circuit, and that's what this tester tests to. So if you get this screen here, you know that your large cables are connected properly and your small cables are connected properly. Otherwise, it'll pop up a screen saying large leads not connected or small leads not connected. So if you're at this screen, you're good to proceed. Down below, it gives you a load voltage and a battery voltage. So my load is my large cables. My battery is my battery voltage at the battery pack. Right now you can see they're about the same. It's because there's no load on the circuit. Until I apply a load to that circuit, there's not going to be a difference. You could have one little strand of wire hanging on between the starter and the batteries and still get this voltage. But if you applied a load, that would give you different results. So now we're going to simply start the test. So I've got good starting voltage drop. The beauty of this tester is it points out exactly the voltage drop on each leg of the circuit. So my positive voltage drop is 0.169 volts. My negative voltage drop is 0.213. And remember when I said RP 129A states 1/2 volt drop at 500 amps? It's the positive and negative leg together. And this one adds up to 0.382, so we're under that spec at 500 amps. So it provided a pass test. It also tells you what these cables are good to. These cables are good to 718 amps at 0.55 volts. It also gives you an analog readout on the positive voltage drop. 0.169, negative 0.213 volts. And again, AmpNet, you can hit the AmpNet button and shoot this data to the cloud, or it'll go to the cloud when it sleeps. It's the end of test. So I know that I've got good power, my batteries are in good shape, I've tested my cables, I can deliver that power from the batteries to the starter. If it still won't crank, it's likely going to be a starter issue. So we can use this tester to test the starter. So now we're going to go over testing the starter itself. So we're going to go into individual tests. We're going to select the starter test. It gives me a diagram of how to make this connection. We just previously tested the batteries, and then the starting main cables themselves. So the cables are already connected in that manner. But connect the large leads to the starter, small leads to the start battery pack. So we're going to hit continue. So it brings up a question, does the vehicle crank? So if it doesn't crank, hit no. We're going to hit yes, so we can continue with the starter test. So you have a start button, so now you're ready to begin that test. Below it also gives you the current battery voltage. Pretty much throughout the whole testing process, you're always going to receive a battery voltage. So we're sitting at 12.59. So we're going to hit start, and it's going to walk me through some other prompts to take. So now it says turn the key to the run position, turn off accessories, wait a short while for the ECU to power up before proceeding. So make sure the gauge is sweet before you proceed. This is where it's really handy to be able to remove this tablet and go up in the cab and do all these prompts. So I'm going to go up to the cab right now. So I'm going to turn the key to the run position. And turn off all my accessory loads. Right now I've got my the door open, so you want to make sure all the doors are shut. Radio's on right now, so I'm going to turn it off. I've got the, notice the windshield wipers were on when I got in, so I want to make sure those are off. So I'm going to hit OK. So it says running starter test. Next thing is pops up a picture of an engine. It says start the engine. And it's detecting that the engine's not running right now, so I'm going to start the engine. So it says enter the number of cylinders. We got 4, 5, 6, or 8. Hit OK. Test is finished. Turn off the engine. So I shut the engine off. I'm going to hit OK. And it gives you your results. It says I have a good starter. Beginning voltage is 12.27. Minimum cranking volt is 10.99. My cranking current, or my amperage, is 939 amps. My cranking RPM is 107 RPMs, which falls into that pass criteria. 8 cylinders, and my cranking time is 1.22 seconds. So that's how you properly test a starter using the BCT-460 Autometer tester. Now we're going to test the charging main cables. First and foremost, the first step is always testing the batteries. Make sure you have the power. And when diagnosing a charging issue, got to make sure you can deliver that power to the alternator. So we're going to go into voltage drop feature on the tester on the charging main cables. We mentioned the adapters that are included in this kit. Several different adapters. Just makes it really easy to connect to the alternator. So we're going to connect to the output post on the alternator, and we're going to pick the adapter that fits. Go ahead and clamp that on. Most of the time there's really not a good ground location where you can screw in these adapters. But right here you can see the ground cable. We're just going to connect to that. So I've got my large leads. Connect my positive to the alternator's output post, and my negative to ground. I'm going to go into individual test, and I'm going to go into voltage drop test. Now I'm going to select my charging cables. Again, it pops up very intuitive, pops up a diagram on how to make this connection. Again, I got to have 2 points of reference to measure this voltage drop. So I'm going to also have to have my external volt leads. So I've got my large leads connected to the alternator. I'm going to take my small leads. I've already got them connected to the battery pack. And it's not going to let you proceed unless you have a good connection. So right now it's saying I have a bad connection on my large leads. So I'm going to figure out why that is. It could be corrosion buildup, loose connection. It's just not getting a good electrical connection on those to that alternator. So might have to switch to a different ground location, get on the ground bolt or something. And you can see that screen went away. So if that screen goes away, you know you have a good connection. And another good indicator is you have your load voltage and your battery voltage below. If you have voltage on both, you know you have a connection to your battery pack and your alternator. So the next step is enter the rated alternator output. I'm going to hit enter. So we're going to look at our alternator and determine what the output amperage is. So we're checking the charging main cables on a 160 amp alternator. So we're going to enter that on the tester. So hit enter. 160. Oops. You got to make sure everything is deleted from that field. And hit 160. And this tester is going to test to TMC RP 129A, which states you're allowed the rated alternator output. You're allowed a 1/2 volt drop at that rated alternator output. So one thing to keep in mind is if you started with a 160 amp alternator and you want to upgrade, you really need to take in consideration your cables. You may need to go up in size on your cables. So it's not as simple as just changing the alternator. You really need to consider cable sizing as well. Again, it's all about getting that charging current back to those batteries and falling within that TMC RP spec. So we've entered 160 amps. We're going to hit start test. And it says I have good charging voltage drop. It walks me through each leg of the circuit. My positive voltage drop is 0.302. My negative voltage drop is 0.118. Added together, that's 0.420 volts. That's my voltage drop with the positive and negative circuit added together. And that is at 160 amps. So again, if you upsize your alternator, make sure you consider looking at cable sizing as well. These cables are good to 189 amps at 0.500 volts, so a 1/2 volt. That's the end of the test. So now we're going to go into our alternator test. We're going to actually test the alternator on this vehicle. We've looked at our batteries. We load tested our batteries. We made sure we have the power. Now we want to make sure, we've also tested our cables to make sure we can deliver that power through those cables to those batteries. So now the next step would be to test our alternator. So first step is connect your large leads to the alternator itself. Positive to the output stud on the alternator, negative to a ground location, either a ground bolt or a pad mount ground bolt, just a good ground location on that alternator. Then we're going to go into individual tests. Go to alternator test. Again, this gives you a really good diagram of how to connect these cables in this circuit. Again, large leads to the alternator, connect my small leads to the battery pack. Again, my small leads are connected at the bottom of the tester. And then I've ran my small leads over to my battery pack. So I'm going to hit continue. So now it's going to run me through everything that alternator is going to rely on to operate properly. The first thing, it gives me a checkoff list. So the first thing is inspect the belt for cracks, glazed surfaces, and fraying. Again, everything that alternator relies on, you just want to make sure your belts are in good shape. Inspect the belt for proper tension. A loose belt on an engine and over that pulley could be the cause of why you're not getting the output that you need on that alternator. It could be slipping on that pulley. So you want to make sure you inspect the belt for proper tension. Cable connections. You always want to make sure you inspect all your cables for loose connections, corroded connections. All that's going to build up resistance in that circuit and could be the reason why you're not being able to deliver that power from the alternator through the cables into that battery pack. So you can simply just check off each one of those as you go. So now the next step is enter the rated alternator output. So I'm going to hit the enter button. And I know that this alternator is a 160 amp alternator. So I'm going to hit 160. And I'm going to hit start. So it's preparing for the alternator test now. So this is where it's really handy to have this as a removable tablet, because you can remove this from the load module and take it up in the cab with you to perform the rest of the test. It says turn the key to the run position, wait a short while for the ECU to power up before proceeding. So I'm going to turn the key to the run position. I'll let my gauges sweep, my ECU to power up. I'm going to hit the OK button. It gives you a nice picture of an engine. It says start the engine. So you can see the tester says hold it idle at about 1,000 RPM and wait for voltage to stabilize. And right below here I can see my voltage. So I'm going to rev up to 1,000 RPM. Let that stabilize for a minute. Then I'm going to hit the press when stable button. Now it says rev to governed speed, or about 2,500 RPM. And it automatically starts that test for you once you do that. So now it says return engine to idle and turn off engine. I'm going to hit the OK button, and it's going to give me my results. So voltage regulation, so I'm regulating at about 14.2 volts, which is about typical for an alternator. My diodes, 1.47 millivolts, charging current 131 amps. Then it gives you that same readout in an analog. Hit the AmpNav button to send it to the cloud, or wait till the tester goes to sleep. Print your results if you'd like. But that's the end of the alternator test.